Hello everyone and welcome to today's episode on this very channel. So today's lesson is just a continuation of what we did in our previous lesson. And as I promised that in our next lesson or in today's lesson, we are going to take examples on linear operators. If you haven't yet subscribed to the channel, kindly hit on the subscribe button for me. So let's do a small recap on what we did in our previous lesson on linear operators. So we said that for an operator to be a linear operator, then it must satisfy certain conditions. So we give out the conditions that these operators must satisfy in order for them to become a linear operator. So we said that if u is a function and then c is a constant, and then L is an operator, then the first condition is that LCU might be the same as what CLU. So this is the first condition. And then the second condition is if we are having two functions, so we are going to add another function to this, let's say v. So we have L u plus v should be equal to Lu, that is L operating on u, plus L operating on the function v. So these are the two conditions that we said in our previous lesson that an operator should be able to satisfy in order for it to become a linear operator. So we are going to look at this particular example on the board, which says that given that L is an operator, we want to show that L is a linear operator. We want to show or verify that L is a linear operator. So in doing that, we are going to apply these conditions. If the operator L satisfies these two conditions, then we can say that this operator L is a linear operator. So we have our solution. So we are letting u be the function, and then c be a constant, and then our L, which is what the operator. So first of all, we have to find Lu, that is L operating on the function u. L operating on the function u. So our operator is what? Del x. So the operator operating on the function u, we are just going to attach the function to the operator. So we have u, and then we have plus del square del y square. We are just going to attach the function to the operator. So L operating on u, we have this. Then we move on to L operating on cu. L operating on cu, and we said that c is our constant and then u is our function. L is the operator. So our operator is what? Del x operating on cu. So we are going to attach cu to the operator. So we have c and then u, and then we have plus y del square del y square. We are just going to attach the constants and the function to the operator. So we have cu. Now from here, you can see that we are having c and then c here, right? So we can bring c out. So our c is out. We are left with what? Del u del x. So we have del u del x plus y. This c is out. We are left with del square u del y squared. So we are going to have this c is here, Now you can see that what is in the bracket is the same as LU. Del U, del X plus del square U, del Y square is the same thing here. So in place of this, or what is in the bracket, we can replace it with LU. So we have L and then U. So the first condition is satisfied, which is that LCU is equal to CLU. So the first condition is satisfied, LCU. Then we move on to the second condition, which is this. So with this, we are going to add another function. So we have U and V are going to be our functions. Then we are saying that L operating on U plus V should be the same as L operating on U plus L operating on what? The function V. So first we have to find our LU. That is the operator operating on the function U. Already we have LU here, so let's write it. Del U, del X plus del square U, del Y squared. Then we find what? LV. That is the operator operating on the function V. So we have the operator del X. We are just going to attach the function V to it, plus del square V del Y squared. Now once we have this, we are going to start from the left. The left, we are having L operating on the function U plus V. So our operator is what? Del X, and then it is operating on the function U and V. So we are going to attach U plus V to the operator. Then we have plus. We are writing this, so plus Y. Oh, so we have Y here. So let's attach it. We have Y here. So we have Y, the square. Then we have U plus V all over what? The Y squared. So from here, we can expand the bracket to have del U plus what? Del V all over del X. And then we have our coefficient variable Y. Then we expand this, we are going to have del squared U plus Y del squared V. And all of this is over what? Del Y squared. Now we can split this and write it as del U del X. Then we have plus del V del X. Then we have our plus here. We can also split this and write this as Y del square U all over del Y squared plus Y del square V all over what? Del Y squared. So for me, what we are going to do is we are going to group the function with the U together and then the function with the V together. So we have del U del X. Then we have this is also a function of U. So we have plus Y del square U del Y squared. Then we put them in a bracket. Then we have our addition. Then we have del V del what? X plus Y del square V del Y squared. We put them also in a nice bracket. So from here, you can see that what is in the bracket here is the same as what? LU. So LU, we are having del U del X, del U del X plus Y del square U del Y squared. So in place of what is in the bracket here, we can write LU. So we have L operating on the function U. We have our addition. And you can see that what is in the bracket here is the same as what? LV. So in place of this, we can write LV. L operating on V. So we can see that the second condition is also satisfied. So therefore we can say that the operator L is what? A linear operator. Very, very easy and then simple. Let's look at another example. So this is a second example that I want to look at. Given that P is an operator, we want to show that the operator P is a linear operator. And for it to be a linear operator, then it must satisfy the two conditions that we have outlined. So the first condition is PCU must be equal to what? CPU. So P is the operator, C is the constant, and then U is what? The function. So we have U to be the function, U be the function, and then C be a constant, and then we have P be the operator. So that for that one we already know. So we have the first condition, P CU must be equal to what? CPU. So first of all, we have to find PU. That is the operator P operating on the function U. So we have PU. So PU means we have to first write what? The operator. The operator is what? Del X. Operating on the function U, we are just going to attach the function to the operator. Then we have plus X del Y, and we have what? U. So this is what? PU. Now once we are done with PU, we move on to the condition PCU. PCU. So P, we write what? The operator del X. We attach the constant and then the function to the operator. So we have CU. Then we have plus X del CU all over what? Del Y. Now from here, we can see that we have a C, and then C here, we can bring our C out. We will left with what? Del U, del X. Then we have plus X. This is out, we are left with what? Del U, del Y. Now from here, you can see that what is in the brackets is the same as what? PU. So in place of this, we can replace it with what? PU. So we have P and then U. Now this is here. So we have PCU is equal to what? CPU. So the first condition is satisfied. Then we move on to the second condition. So with the second condition, we are going to add another function. So we have U and V be the function. And then we are going to include what? A constant C1 and C2 also be the constant. Then we are saying that P C1U plus C2V should be the same as C1 PU plus C2 PV. So what we are going to do is we are going to find our PU and then what? PV. So from here, our PU, that's P operating on the function U, we are going to have the operator is what? Del X, so we have U, and then plus X del Y, we are just going to attach our function to it. So that is P operating on U. Then we move on to P operating on the function v. We are going to have the v, the x plus x, the v, the y. Then we start with the left hand side. So we have P C1U plus C2V. P in the operators, we are just going to write it del x operating on C1U plus C2V. We are just going to attach the whole of this to the operator. So we have C1U plus C2V. Then we have plus x. The operator is the what? Y. Then we attach C1U plus C2V. So at this point, we can expand the bracket to have del C1U plus del C2V all over what? Del x. Then we have x. We expand the bracket, we have del C1U plus x del C2V, and all of this is over what? Del y. Now we can split this into two. So we have del C1U all over del x plus del C2V all over what? Del x. Then we have plus x del C1U all over del y plus x del C2V del what? Y. Now after splitting, you can see that we are having u, and then we have the v. So we are going to group the function with the u's together and then the function with the v's together. So we have del C1U and then we have del C1U. So we are going to group that together. So we have del C1U del x plus x del C1U all over del y. You group it, you put it in a nice bracket. So we have plus del C2V all over del x plus x del C2V all over del y. Let's continue from the top here. Now from this, you can see that we have C1, so we can bring C1 out. So we have C1, we are left with what? Del U, del what? Del x plus x del U del y. Then move on to the v side. We have C2, we can bring C2 out. We are left with what? Del v, del x plus x del v del y. Now you can see that within the bracket is the same as what? Pu. So in place of the whole of this, we can write what? Pu. So we have C1 and then we have Pu, then we have plus, so we have C2, and the whole of this, or what is in the bracket, is the same as this. So in place of this, we can write what? PV. So we have PV. So you can see that the second condition is also satisfied. We have PC1U plus C2V is the same as what? C1PU plus C2PV, which is the same as this. So we can say that the operator P is a linear operator. Very, very easy and then simple. We are going to look at the last one and then away bars. So So we want to show that the operator M is a linear operator or not. For it to be a linear operator, then it must satisfy the two conditions that we have mentioned. So we are going to start with the first condition. So we have M, the first condition is MCU should be the same as what? CM what? U. So this should be the same as that. So first we have to find what? Our MU. M operating on the function U. Our M is what? Del X all squared. Then we attach our function to it. Then we have plus. We have del Y, all of this squared. We attach our function to it. So M operating on U is what we are having. Then we move on to the first condition. So we have M CU. Our M is what? Del X, and all of this is what? Squared. So we are going to attach CU to the operator. Then we have plus del CU all over del Y, and all of this is squared. Now you can see that we have C and then C here, but it is squared, so we can bring C squared out. We'll be left with what? Del U, del X, and then we have, and all of this is squared. Then we have plus. The C is out, we are left with what? Del U, del Y, and all of this what? Squared. Now from here you can see that what is in the bracket is the same as this. So in place of this, we can write MU. So we have C squared, and then we have MU. Now let's see. So we are saying that with the first condition, MCU should give us CMU, but it is giving us C squared MU. So we can see that this is not giving us this. So we can see that this operator is not a linear operator. So the M is not a linear operator because the first condition has failed. If the first condition failed, there's no need for you to go to the second condition. Then you are done. Very, very easy and then simple. See you tomorrow. Bye bye.